Welcome to this short presentation about workspace utilization with me, Dag Koenig from Microsoft Sweden, where I work as a technical evangelist, working with cool companies and their cool projects. Have you ever wondered about desks in your offices? That you have the right desks in the right space, that you have the right types of desks. Desks that are fixed or desks that you can change the height of. This can workspace utilization help you to answer. Conference room. Do you have the right size of the conference room? Do you have the right type of conference rooms? Do you have the right furniture in the conference room? This and how it's utilized can workspace utilization help you answer. And how about restrooms? You know, you need to go when you need to go. And then you want to have a restroom nearby that are free and also clean. And that workspace utilization can help you answer to. And the last but not the least question, the question that we all ask ourselves all over the world, every day, is it too hot or is it too cold in the office? That can we answer also with workspace utilization. So what is office utilization or workspace utilization? It's the possibility to utilize our assets in a better way, to help our customers, our workers, to be more efficient. But it's not only utilization of space and time, I must say. It was really nice to say time. It's also about power consumption and our environment. To use our assets, to use our offices in a really great way. And that's what we'll talk about today. So let me introduce Project Anero, a project that we as Microsoft did together with Intel and Janssen Networks this fall. And in that project, we installed a bunch of sensors in the Microsoft Office in Sweden. And we used that to leverage all the tracking from that kind of sensors to see what we could get from them. So the first thing we want to do was to have a real-time floor mapping of our office. In our office, we have an open space policy, or open office policy. We don't have any dedicated seats. And sometimes in the morning, we really need to run around to find the right seat for us that is not occupied. So this is a real-time mapping of our office, it's just on one floor, but anyway. But now when we have this kind of data, we can do so much with it. So of course, we aggregate the data, we store the data, we analyze the data in Power BI. And we have so many reports and some findings also. We have been running this now for 8 months. I'm sorry to say that I can't show you any Power BI reports because I really want to show you more the solution and the architecture of the solution. So the first thing we did in our solution was to work with Janssen Networks. I really like Raspberry Pi. I really love them for prototyping. And it's really fun to have cables all over the place and LED lights blinking and so on. But in the production environment, you need production sensors. And what do I mean by that? You have to think about security. You have to think about battery. These sensors can live for up to 10 years without switching the battery. You need to think about how you install and maintain these devices. As you know, almost all buildings, office buildings, are already existing today. We need a way to refit these sensors into already existing offices. So it's very important when you work with sensors and we work with IoT that you have real sensors. Don't try to use your own Raspberry Pis. Just do it for prototyping. In our case, we install the sensors underneath each desk, as you see here, probably, no? Okay, it was a small video that showed that we have a sensor underneath each desk. We have also sensors in the conference rooms and in the restrooms, and we have other sensors also for CO2 levels and so on in the office. So here is the architecture. And as you know, more boxes, higher salary. So I have a really good salary. I'm just kidding. It's not that complicated as you can see from the first time when you see this. I have drawn 2 lines here, a blue line and a red line. Do you know why? That's because I use an architecture called the Lambda architecture. Don't confuse the Lambda architecture with Lambda functions. It's not the same thing. The Lambda architecture is a more data-driven architecture that tries to get a better flow through the system for your data. And one of the main things with the Lambda architecture is the streams that they have. In my case, I call it the cold stream, that's the blue stream, and the red stream, that's the hot stream. So if you look through this diagram, the first thing you see is that we have a Jansi gateway. So Jansi is doing the sensors with a field gateway, of course, so they can leverage, for example, long battery life. And they have also part in the cloud. And from their cloud, they have created the gateway to Azure. The next thing you see is the Event Hub. And why not the IoT Hub? We should talk about IoT Hub. Why I'm from Microsoft. But it's 2 things that was part of the decision to use the Event Hub instead of an IoT Hub. The first thing is we don't need the device management capabilities in the IoT Hub. The device managed capabilities is already existing in the Jansi network. They have a really good device management, very good. We don't want to copy it. The other thing is that we only use it for telemetry. We have no commands yet from Azure to the sensors. This will probably change in the future, and we will even switch to the IoT Hub if we have the possibility later. The next thing that I really love in Azure is Stream Analytics. I really love Stream Analytics. It's really great. Then we see that the cold path and the hot path diverge. On the hot path side, we go by service bus topic to web server. And the web server is using Signal R to send the commands, messages to a single page application. And that's what you saw before, the real-time map. The blue the blue path, there we used SQL database. And be really, really aware here. We don't store everything in SQL database. We just use SQL database as the data layer for Power BI. And that's a really big difference. Because if you try to store all your data in a SQL database, you're probably not doing it right. So we store all the data in the blob storage from the Event Hub instead. So follow me to a journey now, where I do a code example of the hot path. The first thing is that I really need a simulator, because I don't have the Jansi network up and running here. And now I want to be a bit biblical, making King James, Charles Heston, 10 Commandments voice, and say, you shall have a simulator. It's not the tips, it's a law. You shall have a simulator. Don't try to use your devices as such. Use the simulator so you can have the flow, control of the flow through your system, and test it in that way. The next thing I will show you, of course, the Event Hub, and you've seen that so many times. Stream Analytics, of course. And here, I want to show you something new. I haven't seen this in a demonstration yet. Of course, I haven't seen so many demonstrations about Stream Analytics, but I really want to show reference data. And reference data is a part of stream analytics that are really, really, really important. And I will show you why. Then we use the service bus topic queue to send messages from stream analytics to the web server. And here we have a SignalR and a WebSocket, so we send it out to the web browser. So let's do it now. So here is my simulator. And the simulator is not that fun, not as fun as they had over there. But anyway, thank you. It's just a console application I have built. I built it, and sorry about that, it's the wrong project. Here's the simulator. I didn't saw that. No. Okay. The first thing I do in my simulator, of course, I have a storage of the devices I want to simulate. So I have done that just in a small file that I read into the program here. And after that, I build an internal device structure that I will use in the simulator. And then I simulate two types of things. I simulate areas, and areas is such type as desks, conference room, restrooms, and so on. And these kind of assets is more about event-based, so they will be free or occupied and so on. Then I also simulate some other things, and in this case I simulate temperature. And in that case, I mean, here I simulate more status changes, so things that happen every 30 seconds, every minute, and so on. So I have already copied a connection string from my Azure account, so I just start this. And now we probably have the simulator running. And excuse me, or you don't see it, but I'm a Swede, so I use comma instead of point. I hope it's okay for you Americans. You need to read to learn to understand our number system also, I think. Okay, so now back to the portal. Okay, reload. So now we have started the simulator. We use the event tab. I have already pre-baked the event tab. I already pre-baked also the service bus, the storage account, and the stream analytics. So now the next step is the stream analytics part. So I will open the stream analytics here. And I also pre-baked the stuff that you have seen so many times. The input from event tab and output to service bus topic. I want to show something new. So I want to show you a thing that you maybe not have seen before. So we will try to we will create a new input. Have you ever wondered this source type, why it can be data stream or reference data? Sorry about, I'm trying to go into, I'm trying to zoom. Here, this data stream or reference data. I will now show you the reference data. So I will set it input ref data, and I will use reference data here instead. A reference data is a possibility to create blobs in Azure Storage account and join that into the stream. And I use it, for example, for get additionally metadata of the sensors. So I will use this storage account. And here is a very important part. To make stream analytics, beware where the file is in the data, in the storage. You need to create a data path here. So I hope I will create the right one. Otherwise, this demo will not work. And I also have the possibility to insert functions here. So I will say that I want it to look in a directory structure with a date and with a time, and looking for a file called asset.json. And of course, I'm from Sweden, so I really like this date format, and I like this date format, time format. So let's go back and save it. I want to show you also the file. So I go to Storage Explorer, and here you see that I have already done the right structure, directory structure of this. I have it was 2 days ago I started at that time, and here is the file. So let's see how that looks. Let's go out again, open that file. Come on. And here you see that I have more information. So sorry about that. I will enhance it here also. So here you see the external asset data is the data that I got from the Yancy flow into Event Hub. But here I got also more information. I got information about what kind of area it is, in which floor this sensor is installed, and so on. So I really need this information to get more information into the system. So let's go back to the Stream Analytics. Here it is. And we go back here and look at the query. So this is a rather simple query. And I should say that we utilize Stream Analytics. You can do so much stuff here. But the thing that we do is the following. The first thing is that we use the with keyword up here to create a temporary table inside Stream Analytics. And we use that to transform the JSON that we got from Yancy, because the JSON from Yancy is a rather advanced hierarchical model, and we want to flatten it out. So we do that by flattening in 2 steps. First here, where we get the input from the Event Hub here, and then we do it again, and we get a reading event temporary table that are much easier to use for us in Stream Analytics. And the last thing we do here is the very, very simple thing. We just transform the data. So here you can see how we transform the data from the external data model to one internal data model that are more used in our system and is better for our purpose. And here you see also the interesting thing about the joining of the reference data. So you see the reference data here is joined with the Stream Analytics data from Yancy on this external asset ID. So let's go back and start this. So we go here and start. And this will take maybe a minute to start. So let's go to the last part of the demonstration, the web server or the web application. So the web application is built around a singleton that we have here. And in that singleton, we first connect to a service bus client. And then we add a new message to the event handler on message. So here, all messages from the service bus topic that was created in the Stream Analytics will arrive. And I don't have the time to talk about Signal R, but Signal R is very, very fun to work with, and I just want to show you one thing. Signal R has the possibility to create same function on the server side as on the client side. So this asset status changed is the same function on the server side. So when I call it on the server side, it will be called on the front end, in the HTML. So here is the HTML, and well, here is the call, asset status changed. And this is a rather interesting page. This page is very simple. It just uses V3. V3 is a data document framework that I really, really, really love. And it's the same framework that Power BI used for their visualization. So it's really great for visualization. It's using a SVG map, and the SVG map is over here. And the SVG map looks like this. So here you see the floor. And the thing that it connects with the HTML is, if I click here, you see that I have an ID. So the ID here is room 1062. So let's start this. And hopefully the Stream Analytics job is running now. No, we had some problem here. I had that earlier today. See if I can get it to work in the small time I have left. Wow, sorry about that. I tried to open the page again. Oh, sorry, I can't do that. My time is up. I want just to show you the last thing here. If you want to look more to this solution, everything is in GitHub except the Power BI stuff. So download it, work with it. It even has a deployment script, so you can get it up and running in Azure. Thank you.